In this example, we're given 24 unsuccessful applicants with a mean age of 42.3 and a sample standard deviation of 8.3. And then we're given 21 successful applicants in a sample, and their mean age was 39.6 with a standard deviation of 6 in that sample. We want to test the claim that unsuccessful applicants are from a population with a higher than the mean age of successful applicants. I think I have a wording issue there. And we want to test this claim at a 0.05 significance level. All right, so first of all, let's decide if this is a mean or a proportion problem. And the fact that we're talking about mean age and we want to test the claim that the mean age of unsuccessful applicants is higher than the mean age of successful applicants. So that means our claim is that mean 1, that means the mean age of the first group is higher than the mean age of the second group. The opposite of greater than is mean 1 is less than or equal to mean 2. All right, looking at which one has the equal sign, the opposite would go with our null hypothesis, so we're going to change that to equals. That means our alternative hypothesis corresponds with the claim. And then to figure out what kind of test it is, I look at the alternative hypothesis. Greater than points to the right, so this is a right tail test. And so now we have to figure out what is the test statistic. So I'm going to throw that into the test statistic formula for two means. I simply take the first mean, sample mean that is, 42.3 from the unsuccessful applicants, and I subtract the mean from the other sample, the successful applicants. Now I'm going to divide that by the square root of the first standard deviation, which was 8.3, and I'm going to square that and divide by the sample size of the first group. And then take the second standard deviation and divide by the second sample size. Okay, let's throw this into our calculator and I'll show you how to do it in one line. Group the numerator by parentheses, 42.3 minus 39.6 divided by, and then call up the square root in parentheses, 8.3 squared, that's the caret 2, divided by 24, plus 6 squared, or you could just type out 36 if you know that off the top of your head, divided by 21. And that gives me, let's call that 1.261. Okay, now I need to find the p-value for this. There is a slight problem because if we're using the t-distribution table, we can't get the exact p-value. So I'm going to show you how to get the range of p-value on the table, and then I'll look at how to get the exact p-value using a spreadsheet. All right, so first of all, we're just going to get the range of the p-value and see what that can tell us. So what I need in order to look up the p-value, I need my test statistic, 1.261, and I need to know my degrees of freedom. So let's find this test statistic 1.261 on the t-distribution table. Keeping in mind that the degrees of freedom we're going to get from the smaller of our two n's, that is 21 in this case, and we subtract 1 from that. So that is, we take our degrees of freedom to be 21 minus 1, or 20. So I'm going to look in row 20 and try to find 1.261, my test statistic. Now I'm looking across here. I don't see 1.261. I see 1.325 is the closest, and that means 1.261 would be somewhere over here to the far right. So to find the p-value, I go up from there, and this is a right tail test, so I'm going to look in the area in one tail, and I'm over here to the right of 0.1. So notice the order that these numbers go in. They go from small to big. So if I'm over here to the right, that means my p-value is bigger than 0.1. So I know that my p-value is bigger than 0.1. I don't know what it is with this method specifically, but I do know that it's bigger than 0.1. And then I compare my p-value to the significance level. So if my p-value is bigger than 0.1, it is certainly bigger than 0.05. So for that reason, my p-value is too big. I fail to reject the null hypothesis. And if I fail to reject the null hypothesis, I'm going to go ahead and cross this other one out because I didn't reject the null hypothesis, and that means the opposite of my claim is possible. So there is not enough evidence to support the claim based on this sample data. Now, if I didn't want to use or if I wanted to use spreadsheet like Google Sheets instead of the normal distribution table, I could use the tdist function, and I'll need my test statistic 1.261 and my degrees of freedom 20 and my tails is 1. And that gets me a p-value exactly of 0.1109. So from Google Sheets, I know the p-value is 0.11, which indeed is bigger than 0.1. So I could figure out if on this example the homework asks you to find the range, knowing that my p-value is 0.11, I could select the option that says it's bigger than 0.1.